Good afternoon all. So in the previous lecture, we have discussed about the load, about what is the pipe, what are the different uses of pipe, what are the different classifications of the pipe, and the various pipes load equipments that are used for the installation of the pipe. So these things we have already discussed in the previous class. So now we will discuss how the load carrying capacity of the pipe is calculated. Right? So the pile load capacity is calculated by the three methods. One, we have already discussed about it. The load carrying capacity of a pile group is calculated, right? So pile group is basically there is a single method. You just see, you can say this is the similar nature of a pile. This is suppose the pile which is having pointed bottom at the edge, and here we are trying to rest this pile over the hard strata. If suppose it is resting over the hard strata, so naturally the hard strata will give more or equal resistance from the bottom, and therefore it will be in a stable condition, right? So when this will be acting or this will be raised over the hard strata, in that case we are saying that this is the end bearing pile where the tip resistance is acting, means the resistance is acting at the tip of the pile, where the cross sectional area at the tip we are taking into consideration. But always remember that piles are never installed in a single manner over the field. The piles are always inserted in a group, and there is a minimum group of 3 piles. The 3 piles which are installed in a triangular pattern. Suppose this is the 3 piles. All these 3 piles are connected with the help of pile gap at its top. Right? So here, I just wanted to show you one picture, one model which we have prepared in our laboratory. You can see these are the different piles, and these piles are just placed like this over the hard strata. Right? Suppose this is the hard strata at which we are resting the pile, and all the pile, once it is installed in its required position, then all the piles are connected with the help of pile cap. You can see this is the pile cap. So this whole member, that pile cap and the pile will be act as a single unit, right? And that is very similar to the, this unit is very similar to the pier. Now you can see this is the pier. Suppose these are the piles. Now these 4 piles are supposed placed like this, and then it will be just act as a single member. Just only 4 piles circle, so then it will be act as a single member, and this is called as pier. Now this pier, and what is the difference between the pile and the pier? Pile is a slender structural member, whereas pier is a structural member which is having larger cross-section area as compared to pile. So here this group is, whole group is act as a single pier. You can see this is the pile and this is the pier. Now these, suppose these are the 9 piles which are installed or which are inserted into the soil, and then further all the piles are connected with the help of pile cap. Then it will be act as a group. So this group is a single pier, right? So here the load carrying capacity of these pile group is calculated by the different methods, right? So first we will discuss the static method. So the static method is the analytical method, which is more realistic method, where all the parameters are taken into consideration, that is number of piles, spacing between the pile, diameter of the pile. Here is length of the pile, diameter of the pile, the surrounding soil, the soil which is available at the bottom. So all these things we are taking into consideration. Then it will be a static method. So static method is more realistic method and close to the actual value. So this is closed to the actual value. Here all the parameters are taken into consideration. What are the all parameters? Like all parameters are diameter of the pile, length of the pile, spacing between the pile, number of pile, and the soil properties. So all these things are taken into consideration. Therefore, these problems becomes a more realistic problems over which is used over the field, right? So there is another method, that is the dynamic method. Now dynamic method is basically the resistance which has been taken by the soil. Now we all know that this is suppose the pile, and this pile is just inserted by giving the hammer blows at its top. Now if the soil is in a hard condition, In that case, the number of blows will be more. And if the soil is soft, in that case, the less efforts are required to penetrate the pile into the soil, therefore number of blows will be less. Right? So here the resistance is calculated, or the load carrying capacity is calculated from the resistance dynamic loading which is we are giving to the pile, and that is the weight of the hammer. Then free fall. This is the free fall, means how much kinetic energy we are giving to the pile, and the resultant and the work done is in the form of penetration of the pile into the soil. Right? So these are the things. Here it is based on the penetration resistance. So here we are just calculating or we are considering the kinetic energy. Here we are considering the kinetic energy and work done. Right? So these are the two things. Now the third and the very important is field tests. So field tests are the in situ tests which are conducted over the field to determine the load carrying capacity of the pipe, and there are two tests which are mostly used over the field, that is pile load test and another is the cyclic load test. So these two tests are used over the field to determine the ultimate bearing capacity, and here these tests are conducted over the test pipe, actual pipe, or over the test pipes. So these are the different methods which are used to determine the load carrying capacity of the pipe. So today we will discuss first the static method. Now what is static method? What are the different parameters that we are taking into consideration, that we will discuss. So basically, here we will just consider a group of, or we will consider a single pile. Now here we will just consider a single pile. The single pile of D is the diameter of the pipe. Here, diameter of pipe is assumed to be D. Then the length of the pipe, suppose this is the ground level. So here this is the length of the pipe which we are taking into consideration. Here there is some slope. So this is L, and this pipe is being surrounded by the soil. This pipe is being surrounded by the soil, and this soil is present over here. So this is the soil which is available over here, and this is the soil which is available. Also, some soil is available over here. Suppose this soil is a soil of property if there are the different soils. Means there is a layered soil deposit. This is first layer, and this is second layer. Now, what are the properties which are available in this? There will be a C1 and Phi1 and gamma. That is the, if the soil is cohesive soil or C5 soil, in that case it will be C1 is the cohesion in the first layer, Phi1 is the angular shearing resistance in the first layer, and gamma 1 is the density of the soil in the first layer. Right? Then in the second layer, their properties are C2, Phi2 and gamma. So these are the different properties that we are taking into consideration. Now here, this is the load. Suppose we will consider this is Q ultimate. This Q ultimate is the load which is acting over the pipe. Now here, the load is taken by the two parameters. One is when we are resting this pipe over the hard strata. You can see when this pipe is resting over the hard strata, so there will be an equal and opposite reaction which is coming from this side, and this is acting over the cross-sectional area at the tip of the pipe, right? So here, this is called as the tip resistance, and the another important parameter that is called as frictional resistance. Now you all know this pipe is being embedded into the soil, and naturally if it is embedded into the soil, so when we are trying to push this into the soil, the frictional resistance due to the surrounding soil, it is very similar to the action like this. So this soil holds the pipe properly and therefore it will just give resistance against the ultimate load or against the penetration, that is the frictional force which is developed around the periphery of the pipe and into the surrounding soil. So the load is taken by the two parameters. One is the tip resistance which is acting at the bottom. So here this is QP. This QP is the resistance which is acting at the bottom where cross-sectional area of the pipe is taken into consideration. Right? Then there will be the frictional resistance. That frictional resistance is acting over the whole periphery along the shaft. And this is called as QS, that is the frictional resistance. Right? So here, what we just assume, the ultimate load carrying capacity QU is equal to the first resistance is the tip resistance which is acting at the bottom and the frictional resistance which is acting over the periphery. So here the first one is QP and the another one is QS. Now what is QU? QU is ultimate load on the pipe. Then QP is tip resistance at the bottom of pipe, and QS is the frictional resistance over the shaft length. Now here we will just determine the value of QP. So this QP is equal to small QP into A. Now what is QP? QP is the tip resistance which is calculated by the Mayrhof's equation. So here QP is calculated by Mayrhof's equation. What is the equation to determine the bearing capacity of the soil? The bearing capacity equation is QU is equal to CNC plus QN2 plus 0.5 D into gamma into NA. So this is the equation which we will use to determine the bearing capacity as we have discussed it for the shallow foundation also. So here it will be CNC, this is the cohesion component, this is the charge component, and this is the foundation soil component. Now in this parameter, we will just neglect the second term. The second term we are neglecting. So here, the second term is very negligible. As we know, this is the pile foundation as we have already discussed it. So this is the pile foundation group where there is a surcharge is very negligible and therefore we can just neglect this term. So it will be neglected and therefore the equation is becomes therefore the equation of QP is equal to CNC plus 0.5 B into gamma into N. So this is the value of QP, right? Then where this QP is acting, this QP is acting at the bottom or at the tip of the pipe. So which area we have taken into consideration? So here this AP is equal to pi by 4 D square. So what is the D? D is the diameter of the pipe at the tip. Because it is acting at the bottom, so it will be this area we are taking into consideration, right? Then the another is QS. So this QS can be calculated as small QS into AS. So what is QS? QS is basically frictional resistance. So this frictional resistance is naturally in clay soil. Now you can see this is the soil where the frictional resistance is acting, and this QS is basically the parameter which is related to the cohesion. Right? So you can just see this is the cohesion or the soil which is available around the periphery, where cohesion is the important component which provides the frictional resistance to the pipe. Right? And then here we can just consider this is C and into alpha. So with C you will take into consideration. Here you can consider this is CS and this is CP. CP is the cohesion and the at the tip of the pipe, and here along the shaft along the shaft. So here we will just consider this is CS into alpha. Now what is alpha? Alpha is the adhesion factor. Adhesion factor, you can see here this soil may not be in 100% contact with the pile material. This may be like this. Here there may not be a proper contact between the pile and the soil, and therefore this alpha is the adhesion factor. Because there is no proper contact between the pile and the surrounding soil, therefore this alpha is come in picture, where alpha is basically the reduction factor. We cannot assume that there should be a proper 100% contact between the pile and the surrounding soil, therefore some reduction factor that alpha is taken into consideration. Right? So what is then AS? So A is the perimeter at which the frictional resistance is acting, and therefore this AS is equal to pi into D into L, because it is acting over the whole length. Even though the perimeter we are taking into consideration, but it will be acting over the whole length, therefore we will consider this L also. Right? So in this case, this QP is equal to C. This QP is equal to C into NC plus 0.5 B into gamma into N gamma multiplied by pi by 4 B square. Pi by 4 B square, that is the cross-sectional area at the tip of the pipe. Then what about the QS? So here it will be QS is equal to, first it will be C into alpha into pi D L. So this is the QP, that is the tip resistance acting at the bottom, and this is QS. So here you can just determine the value of QU is equal to QP plus QS. So by this way, we can calculate the load carrying capacity of an individual pipe. Right? So here, in this case, now we will consider the pipe in a clay soil. So basically, pipes in clay. So we will just consider the pipes in clay. When the pipes are installed in a clay soil, majorly the pipes are of friction pipe, right? Because in the cohesive soil, the frictional resistance, the cohesive soil, this QS is having more value as compared to QP. Therefore, the pipes are called as friction pipe. These pipes are called as friction pipes. Now suppose here, what is the equation for QP? So in this case, QU is equal to, QP is what? QP is CNC plus 0.5 B into gamma into N gamma into pi by 4 B square. So this is QP plus C into alpha into pi B F. So this is the friction and this is friction component, and this is the tip resistance. This is tip resistance. So here these are the two components. Now if suppose we will just consider the soil is a pure clay. If soil is pure clay, so here this clay when phi is equal to 0, when there is a pure clay, phi is equal to 0, and when there is a phi is equal to 0, in that case NC can be varied. What is NC? NC is bearing capacity factor. NC, and here you can consider N term, that is bearing capacity factors for phi. Bearing capacity factors for phi. If phi is equal to, which varies between phi, if phi is equal to 0, for phi is equal to 0, NC varies between 6 to 9. Varies between 6 to 9, and we are just assuming 9 as a value for a load. Here we can assume it from 6 to 9. NC can be, when we have considered in a shallow dip, the NC value, when there is a pure clay, NC value is taken as 5.7. But here, as it is a pure clay, for pile foundation, this NC is taken as 6 to 9. But in general, for deep foundation, we are considering NC is equal to 9. And what is the value of N gamma? NQ in this case it is 1, and N gamma is taken as 0. Right? So NQ we have already neglected because the term is very small, and therefore N gamma just we will put into the equation. If the value of N gamma is 0, in that case this value becomes 0, and therefore the equation for clay soil is equation for clay soil is QP or QU is equal to 9C into pi by 4 D square plus C into alpha into pi D. So this is the equation for a pure clay soil. Right? So this equation is valid for a trivial pipes in a clay. Right? So when the pipes are installed in a sand, that part we will discuss